Hello, and what we're going to do today is finish up Unit 1. This is going to be Unit 1.3. We're going to talk about European and North American exploration of the ocean in terms of physical oceanography. And we'll start with the European Age of Discovery, as you can see here. Portugal trade routes around Africa, so around the Mediterranean. The countries around the Mediterranean are doing a lot of study around the Mediterranean. They're making it to Iceland and Greenland. They've now made it to North America, and now we're starting to think about circumpolar navigation. Where we're actually having Magellan and Decano. They actually start with this red one, 1519, and you see them moving across South America and out into the Pacific Ocean. So 2 years later, they're here. And then they move over, and Magellan is killed. And then Decano actually finishes it. So we're 22, comes around, and he actually finishes back in Spain for circumnavigating. Magellan is given credit for it because it actually is his ship, or ships. But Magellan didn't make the trip, at least not as a living creature. And then we have Drake coming from England, actually doing the same sort of a trip, although you can see he's doing it at about 50 years later. So he makes it around South America, he makes it around, goes up around the coast, the west coast of South America, Mexico, off the coast of North America, to what we now call Drake's Bay, and then moves back across below the Philippines because Magellan's hatred, or the Philippines' hatred of the white man, for probably good reason. He stays south of that. They both skirt the Indian Ocean, and you can see he goes up the the west side of goes around South Africa, around the west side of Africa, and then back up to England, circumnavigating the globe. Then this is the picture from the front page where we see Cabot going across 1497 to Newfoundland, and we see Columbus making the sail of the ocean blue in 1492, actually landing in the Bahamas, discovering North America well after the Vikings. Leif Erikson had discovered it back in the like 1100s. And then we have Magellan's trip going around. Again, he's killed 1521, and Decano actually finishes. British Isles dominate naval power as of 1588 after defeating the Spanish Armada in 1588, and they do that until around the early 1900s, so the earliest 20th century. We have new technology. We have the magnetic compass, again from China back in the 13th century. We have three-mast ships, which are actually created now for, and this is actually the British defeat of the Spanish Armada, with cannon fire, and you can see there are things, including people, blown up into the air. Had to be really violent. I think they said there were 25,000 deaths in this battle, or these battles. There were about 6 of them. And then we also had maps with latitude and now longitude, with 1569 with Harrison's clock, which we'll talk about, I think, in this slide. James Cooke, 1728, 1799, Endeavour, Resolution, and Adventure, mapped many of the Pacific Islands, did a systematic search of ocean characteristics in terms of currents, depth, and depth pressures. He actually took a marine chronograph, John Harrison. You can watch a video if you click this, discovering this clock. And what this clock basically did was, it was a self-lubricating clock, which is what ships needed, so they didn't get all gummed up and slow down. They had to be able to actually travel across the Atlantic Ocean and come back with less than 1 minute of difference. So the clock was very accurate. John Harrison actually got, I think, 20,000 pounds back in the like 1770s. Actually, he got it a little later because it took a long time for him to actually register him as the winner, and that's the equivalent to like $20 million today, so that's a pretty good chunk of change. Cook's voyages, he actually had 3. You can see the red one, first one, gold one, second one, where he's actually going this way, and then the blue one, the last one, or the turquoise one, where it actually goes both ways. So he's going off this direction, zipping around, coming back in, and you can see coming back this direction. So he actually goes into the Pacific and comes back. The only 2 that actually make it underneath South America are the first and second trips. But he does lots of study um, about oceanography. John Ross and James Ross, distribution of life in the oceans. They started looking at the Arctic and the Antarctic, and they actually found a lot of life, similar life in both locations, and they actually found the amount of life in the ocean lessens as you increase depth. So as you go down, there's less and less life. Edward Forbes actually discovered there's hardly any life way down below, and that was actually attributed to very high pressure, very cold temperature, coldest temperature in the ocean, 4 degrees Celsius, and also no light. HMS Challenger, late 19th century, birth of oceanography. They did seawater chemistry, so now we're starting to find out how much salt and other things that are dissolved in the water, the depth of much of the ocean, temperature readings in much of the ocean, brand new, over almost 5,000 new species, and did sediment samples also with core samples, dropping very heavy pipes with weights on them down into the sediment and pulling them up. They actually discovered the deepest depth, the Marianas Trench. They analyzed seawater from all over, and they classified deep sea sediments, which we'll talk about. And you can see there's their trip, and they did lots of study in the Atlantic. They did lots of it in the Pacific, going around, and so they actually do make it back to the Philippines, and I guess everybody's happy again. And then eventually makes it back around, over, and around, and through into back to England. Then we have Nansen. I'm not even going to try his first name, and they're doing Arctic studies with the Fram, a very well-built ship that they actually took out of Newfoundland. I'm sorry, they took out of Scandinavia, and they actually moved around the Arctic Ocean during the summer. And right here, they actually set their ship and they let the ice form around it. So the ship had to be very well designed because ice expands. It caused lots of pressure on the ship, actually pushed the ship up somewhat too, but the ship had to be very stable and very strong. And then they let the ice actually carry them around the Arctic, and they actually noticed that the Arctic Ocean did have ice currents. There's also Wilfred Ekman, which we'll talk about later on when we talk about density currents, but he comes up with the Ekman spiral, explaining that as water moves in the northern hemisphere, water is deflected 45 degrees to the right, and then water in it for another 45, and it just keeps going and going and going and going. And then if you take a look at the net transport, it's 45 degrees to the right in the northern and 45 degrees to the left in the southern hemisphere. And that actually is what's called Ekman transport, spiral transporting the water. Early American contributions, Ben Franklin, Postmaster General, actually notices that it's very inexpensive to take mail over toward England, but it's more expensive because if you try to come back the same way, it's a very slow. So what they actually did is they went across Africa, down the coast of Africa and back around. But he discovered what's called the Gulf Stream. I actually just pulled this video up today, or this animation up today. This is Earth Null School, and it actually is ocean currents. And let me see if I can find that again. Earth Null. So here's the actual picture that I've got, and if you take a look, you can see the warm water coming out of the Gulf going around Florida, the continental margin, and actually riding along the coast. There's North Carolina and Cape Hatteras and the Outer Banks, which pushes it out away from the coast, and you can see it brings that warm water with lots of what are called eddies. This is a warm water eddy moving in a clockwise direction. These are cold water eddies moving in a counterclockwise direction, and basically what happens is you can sort of see this wrapping around. It's going to pull cold water. Actually, this one would be pulling colder water farther south. So we got cold water eddies and warm water eddies, but basically it brings warm water all the way up toward Europe, bringing warmer temperatures, more moisture, humidity in the air for moisture than you'd expect to find on the opposite side. Because if you look at that latitude, it's sort of the same latitude as what we see up in Canada, where it gets lots of snow and lots of cold. Okay. Then we have Matthew Mullery. He's actually called the father of oceanography. He writes the first oceanography textbook for naval individuals, not for colleges, although colleges ended up using it, and very different than the book that you've got today because it was talking very much of physical oceanography. Alexander Agassiz actually is the United States Oceanographic Research Center, where he actually comes up with more information to put into better and better textbooks. So we're actually starting to get this written down so we can take it to people who are not actually out on the boats. 1925, we had the Meteor, which was a German ship. They had the first echo sounding, so what we actually were able to do is to go out, instead of dropping lines with weights down to figure out depth like they did with the Challenger, they actually used sound waves to bounce off the ground. They also did magnetic studies to find out magnetic fields created by motions in the outer core. And they did gravity studies, actually finding out that there were sections that had more gravity because of more mass. So actually started looking at iron. Deep sampling of the seafloor. 1968, we had the Deep Sea Drilling Project, where they actually had a boat which was created to drill down into the sediments and into even bedrock in the ocean. And you can see they went all over. I'm not exactly sure what the reds and the greens and the blues mean. They could be different trips. But basically what they did is they drilled, and now they can look at the sediments. And when we actually look at marine sediments, we'll do an activity based on these core samples. Modern fields of research for marine biology, marine physical oceanography. You can be a marine geologist, where you actually study the rock. Geophysics, where you talk about the motion of the rock. Ocean geochemistry, where we talk about the chemistry of the land. We talk about ocean currents. We can talk about climate changes. El Nino, big in the news this summer if you're paying attention to oceanographic news. And you can also go into marine biology. Early support of plate tectonics is also going to be through this study, where we get geophysics applied to oceanography. Harry Hess in the 1950s actually develops the idea of the seafloor spreading concept, where the Pangea was there and the seafloor actually started to spread. And it's not seafloor spreading died because it's not just the seafloor, it's the whole plate idea. Continental crust versus oceanic crust, but he had the idea of the fact that these guys were splitting apart. So he was helping Alfred Wagner from the 1920s by looking at ocean floor. We also have submersibles and ROVs. Submersibles are ships that can take people down. First-hand look at the ocean seafloor. We looked at hot vents. We looked at unique ecosystems in those hot vents, which we'll talk about later. Problem is they're very cramped. You had to heat it and cool it, and you had to bring oxygen. So we have to, you have to make this little sphere down here strong enough. Trieste had one right there. Here's the Japanese, and I'm not going to even try that. Sinkia, that little section. All the rest of this stuff is for buoyancy. And then we had the sea cliff, where the people would have been right about here. So you can see depth. This is in kilometers, so Alvin makes it down 4. And we can take the Trieste, which actually made it all the way down into Challenger Deep, like 11 kilometers down, 10,300 and some odd. Then we had the remotely operated vehicles, ROVs. These have instruments to collect it. They don't have to worry about cramped space. They don't have to worry about heating and cooling. They don't have to worry about oxygen. The only thing that they've got to worry about is they've got to worry about power supplies, because normally you send them down with battery power, which means eventually it runs low and it's got to come back up to the surface. Or if you have a tethered one, that's a lot of line if you want to especially go down to Challenger Deep. But we can use remotely operated. So you sit on the comforts of a boat. If it's raining outside, you're inside. If it's stormy outside, hopefully the boat's big enough you don't feel the motion. Or you can really even beam this to coast and control the ROV from there, although you do have to worry about a little bit of time lag. Now we do most of our oceanography with satellites. These are instruments on satellites higher up in space. They can measure characteristics of the ocean surface. They can do surface temperature. They can do ice cover. They can even look at real pictures of ocean color to actually see biologic life Plankton is a very important thing, and also changes in sea level based on global warming or hurricanes pulling up water, or just storms. Underwater human habitats. It used to be thought of that we could actually start living underwater. Really, this is limited to the continental shelf because of pressure. If we put this down on the abyssal plain, these things have to be a lot thicker, a lot stronger, a lot harder, a lot more expensive. So limited to the continental shelf, 130 meters maximum. Mainly this was in the 1960s. We do have small ones today, mainly for research. This is actually not real, I don't think. And I know that one's not real either, but they're not very deep, and they're just basically for research. How do people deal with living in those cramped environments? And that's the end. Here's sea surface temperatures. Expect to find warmer water along the poles, the tropics, and colder water up by the poles. You can see 30-degree water located like right there. And this is sort of like an El Nino where warm water belt comes through. And we'll talk all about that when we talk about surface currents. Okay, thank you for stopping by. Appreciate it. Bye-bye.